Hello students, how are you all? Hope you're enjoying all the videos. Today we are going to start with a very interesting topic from physics. Yes, that's light, right? Without light, can you just imagine if light wasn't there, how would we have been able to see such a beautiful world? Will just imagine if light wasn't there, was life possible? Yes, so you can say that light is next to life. Yes, so it's such an interesting phenomena. We are going to learn about it for today's class. We will see how light is reflected, how it is refracted, the phenomena of reflection, refraction, how does light behaves when it is incident or when it is propagated on a plane surface, on a spherical surface, through lenses. What happens when light travels from one medium to another, right? So all these things we are going to learn, we are going to understand how it is possible. Okay, so let's start with it. In today's class, we will study about the reflection of light through a plane mirror. You all know, okay, what is plane mirror? It's our day-to-day routine. Can you imagine by not looking yourself in the mirror and just going out? You have to see yourself once going out. You just have to see that everything is proper, your hair is proper, your dress is proper, you're looking good, right? So it is very important for all of us to see things in a mirror. But have you ever imagined how our image is formed in a mirror? Or how are we able to see ourselves inside the mirror? Is there any change in your image? You are just the way you are. You are of the same size, same shape, same color. You can say the same distance. If you are standing a 2 meter distance from the mirror, you are standing 2 meter distance behind the mirror. Your image is there. Okay. So how are these images formed? Have you ever just given a thought to it? Let us see. Okay. You all must have experienced this phenomenon. Okay, how do you see yourself on a polished surface? Or for that matter, it's not even a plain mirror. You are able to see your images even on your glass panes, window panes, even for that matter, even in water. Okay, as this small little boy is able to see his image in the water itself. Is water mirror? No, water is not mirror. Then why is it reflecting your image? Okay, just give it a thought and keep all these thoughts in your mind, all these questions, and create a curiosity, because we are going to answer all these in today's lecture. Okay, so today at the end of this episode, we will be able to define what is reflection and how the property of reflection is related to light. We will also see define terms related to reflection. So what do you mean by an incident ray, the reflected ray, and normal? We will study what is the laws of reflection. We will also define images as in virtual images and real images. What do we mean by that? Identify the characteristics of images formed by a plane mirror, a convex mirror, and even a concave mirror. Convex and concave are types of spherical mirrors. We will also apply a mirror formula. Now, what is mirror formula? We will go to it. It's a detailed version. Okay. Sign conventions to find out the relationship between distance of the object and the distance of the image. Okay. So let us start. Okay. So we'll start with the phenomena of reflection. Before studying types of reflection, do you know what is basically reflection itself? Okay. Reflection is nothing but when, for example, this is your opaque surface. When a light is incident on this opaque surface, it gets reflected back, right? In simple words, this is what we call as reflection. So whenever rays of light, because light travels from one point to another point, light always has a rectilinear propagation. Rectilinear propagation means it always travels in straight lines. Always travels in straight lines. So when light travels, how does it get reflected, or how does it get, you can say, bounced back from a surface? So just imagine you're sitting in your room and you have just switch on the tube light. Okay, so when you switch on this tube light, rays of light from the tube are released, they touch the wall surfaces, and then again they come back. Within a second, the entire room is illuminated, right? So this is bouncing back of light, is basically is what is called as reflection. Okay, now there are two types of reflection that we are going to study. One type of reflection is your regular reflection. What do you mean by regular reflection? Regular reflection means when the surface is plain, it's smooth, shiny. For example, a plain mirror, for that matter, a plain wall. Okay, anything which is plain, which is smooth, and which is shiny will have regular reflection. So in regular reflection, these, can you see these green, red ones? These red ones are your incident rays. Now, what are incident rays? Incident rays are the rays which are coming from the light. Okay, incident rays. Incident rays which are coming from the light. All the incident rays will always be parallel to each other. Okay, now this is your smooth, shiny surface. So when this smooth, shiny surface, when it strikes the smooth, shiny surface parallelly, it gets reflected back again in a parallel manner. Okay, this is what we mean by a regular reflection. So parallel rays are coming, bouncing back from the surface in a parallel manner. Okay, so these rays which are going back, those are called as reflected rays. Right? There's one more type of reflection that is called as irregular reflection. Irregular reflection is also called as diffused reflection. This concept we had studied in our lower classes in 8th grade, 9th grade. But again, why am I repeating this? Because this is the base. This is the basic. This is the ABC of light. Okay. Unless and until you won't understand this, you won't be able to understand the higher concepts that we are going to take ahead. Okay, so one type of reflection is a regular reflection. Regular reflection occurs when when the ray of light is incident on a smooth and shiny surface. Another type of reflection is called as irregular reflection or diffuse reflection, wherein, what is the difference between regular and irregular? Incident rays are always parallel. Okay, so if this here, your surface won't be smooth, your surface would be a rough surface, it's not a regular surface. Okay, so when parallel incident rays strike these lines, the rays which get reflected back, they are not parallel, they will get reflected back in any direction wherever they touch the surface. Okay, so if you see, the red ones are your incident rays and the blue ones are the reflected rays. So is the reflection proper? No, the reflection is not proper, it's not regular, hence it's called as a diffused or an irregular type of reflection. Right? Okay. Terms related to reflection, we know the ray which is coming from the source of light, this is called as the incident ray. The point where, okay, this is very important, the point where this incident ray strikes the surface, so this blue one is your plane mirror, this is the surface. Okay, so the point where this incident ray strikes the surface is called as the point of incidence. Point where the incident ray strikes the surface is called as point of incidence. Now we know from the point of incidence where it is striking, it will get bounced back, so it is getting reflected. So the blue one is called as your reflected ray, the blue ray. And this particular point is very, very important. It is applied in almost all the concepts of light. It is applied in spherical mirrors, it is applied in lenses, it is applied in refraction phenomena as well. We all at the point of incidence, this is the red one is the point of incidence. At the point of incidence, we always draw a normal. Okay, if you see this dotted line, okay, This is called as a normal. Now, what is a normal? A normal is a perpendicular to the surface, perpendicular to the reflecting surface at the point of incidence. Okay, so wherever we have our point of incidence, we always and always we need to draw a perpendicular at the point of incidence, and which is perpendicular to the surface, because normal, with the help of normal, we will be measuring many things. Okay, so normal is always a perpendicular at the reflecting surface at the point of incidence, right? Now, very important another thing, we have angle of incidence, right? So now what is angle of incidence? Angle of incidence is always the angle between normal and the incident ray. Okay, what is angle of incidence? Angle of incidence is the angle between normal. Can you see this dotted line, which is normal? Okay, so it is this one. Okay, so angle which is formed by the normal and the incident ray is called as angle of incidence. Many students get confused as and they mark angle of incidence like this. This is not angle of incidence. Angle of incidence is not the angle between surface and the incident ray. It is always and always the angle between normal and the incident ray. That's your angle of incidence. In the same way, we have our angle of reflection. Now again, as angle of incidence was angle between normal and incident ray, angle of reflection will also be the angle between normal and reflected ray, this one. So these are certain very basic terms related to reflection. Incident ray, reflected ray, normal, angle of incidence, angle of reflection, and point of incidence. Very important. Okay. Now we have something called as laws of reflection. Again, this was a topic which was there in your previous classes. Let us revise once again. There are certain laws when the phenomena of reflection always obeys these laws. Okay, everywhere, all types of light. We know that the light which we can see is a visible spectrum of light. There is light which we cannot see. Okay, human eye is not able to see that light. That type of light is called as ultraviolet light and infrared light. Okay, we our human body is not enabled, or human eye does not have the capacity to see that type of light. We can only see visible light. Okay, that is called as white light, which is a mixture of 7 colors that we are going to see, okay, in the coming episodes. Now, all the rays of light will always and always obey the laws of reflection. Okay, what are the laws of reflection? The laws of reflection says that the angle of incidence is always equal to angle of reflection. So that means angle of incidence always equal to angle of reflection. These two angles are always congruent to each other. Okay, that's first law of reflection. The second law of reflection says incident ray, reflected ray, and normal. All of these three things, okay, incident ray, reflected ray, and normal. All these three things will always lie in one plane. Now, what do you mean by one plane? We are already familiar with the Cartesian coordinate system. Okay, so this is your x-axis, this is your y-axis. Now, in the upper classes, you will also deal with the third type of axis that is called as your z-axis. Okay, and all these three axes are mutually perpendicular to each other. Okay, these are perpendicular to each other. So there are three planes. We have this xy plane, we have this xz plane, and we have this yz plane. So now, as we are talking about the second law of reflection, so second law of reflection says angle of incidence, angle of reflection, or incident ray, reflected ray, and normal. All these three rays will always lie in one plane. So either it will be in xy plane, it will be in a yz plane, or it will be in a xz plane. Understood? This is just the basic revision that we are going to do. Now, how is an image formed in a plane mirror? Have you ever imagined? We every day, almost every day, we spend hours and hours before the mirror, right? Before going anywhere. Okay, how do I look? Okay, if I do my hairstyle, how am I going to look? Okay, if I put some makeup, how am I going to look? So sometimes hours we spend in front of the mirror, but how are the images formed in a mirror? How are we able to see the way we are, right? So let us see how images are formed in a mirror. Now, consider this object P. Can you see this? Yes, this object P, as this is the object. Okay, blue one is your plane mirror. So for convenience, we will only take two rays. The red ones which you can see, we will only take two rays which are coming, right? So these are the two rays which are coming from the object. Okay. In reality, we will see there are million of rays which are coming from that object. But for our convenience to draw a ray diagram to understand how reflection takes place in a plane mirror, we will take only two rays. So these are the two rays. Now these two rays will strike the surface of the plane mirror. So what do we have then? So over here, we have point of incidence 1, point of incidence 2. What is the first rule? What do we do at the point of incidence? At the point of incidence, what do we draw? We draw a normal. So the gray dotted line is your normal. From the normal, what do? We take another ray, the blue one, which is called as your reflected ray. Okay. And these reflected ray is reaching your eyes. Fine. Okay, now there is just only incident ray, there is just reflected ray, fine, this is okay, okay. But then how are we able to see these objects inside the mirror? If you see, when I take these rays behind the mirror, so for example, this is my point of incidence, again point of incidence, these are the normal. So what I'm doing is, I take these rays behind the mirror. So these dotted lines, if you see the blue ones, I'm taking them behind the mirror. Okay, when I take them behind the mirror, they are meeting at a point, this. Now, we are able to see the image of this object at this point, inside the mirror, right? So this is how images are formed in a plane mirror. This is the object, you are standing over here and you are able to see the reflection of this object here. This is the image. Understood? Clear? Okay. If you again see in the next scenario, now see two rays coming from point X. So my point X dash was formed over here. Another two rays are coming from Y point. Okay. Again, two normals. Again, reflected rays reaching my eye. Again, when I just take them behind dotted lines, so my Y dash point is formed over here. So this is the way your images are formed in a plane mirror. Now, can we study some characteristics of images formed by a plane mirror? Can you tell me? Yes, it is. First of all, it is erect. Erect as in, do you see inverted images of yourself in a mirror? No, we see just the way we are. If we are standing, the image we will see inside the mirror will also be standing. If we are sitting, the image will also be sitting, right? So it is always erect. It's erect. Then it is laterally inverted. Lateral inversion means, what do you mean by lateral inversion? Okay, so if you just take two palms of your hand, okay, touch your hands to each other just the way you do namaste, okay, and just then open your hands, all the 5 fingers on the left and all the 5 fingers on your right. These two are laterally inverted images of each other. Okay, so if you take left hand as your object, the right hand will be the image, laterally inverted image. So that is called as a mirror image. Mirror images are always laterally inverted. Okay. Third thing, it is of the same size. If, for example, this is 10 centimeters, the image will also be 10 centimeters. Okay, it has the same size and it is at the same distance. So if I have kept the object at a distance of 1 meter, I am going to see the object at a distance of 1 meter behind the mirror. Okay, it has never ever happened that if I am standing 5 meters in front of the mirror, I'm going to see my image just 1 meter behind the mirror. That is not possible. That is only possible in spherical mirrors, which we will study in detail, right? So these are the four image characteristics uh, of images formed by a plane mirror. They are always virtual and erect. What do you mean by virtual? Again, we will do this in detail. Virtual images are basically images which are formed inside the mirror. Okay, we will do a quick differentiation between real images and virtual images. Okay, just first of all discuss this. It's always virtual and erect. Secondly, size of the image is always equal to size of the object. Thirdly, image formed is as far behind the mirror as the object is in front of it. Fourthly, images are laterally inverted. So these are the four important properties of images formed by a plane mirror. Now, when I want to differentiate between real images and virtual images. Now, what are real images? Real images are images which are formed on screen. Basically, we cannot see real images inside a mirror. Okay, if you are able to see the image, okay, of any object in a mirror, that image will always be virtual. So we can say it is never formed. It is never formed behind the mirror. Behind the mirror. Here you can say always formed behind the mirror. Why? Because we are able to see. So then how are images formed? Real images can be seen. Always formed behind the mirror. Okay, that's why we are able to see it. Because it's in front of you. Okay. Now, how will real images be seen then? Real images are always obtained on screen. Okay. Real images are always obtained on screen. I'll give an example for this. Virtual can never be obtained on screen because where is the image formed? The image is formed. The image is formed behind the mirror, so we cannot obtain it on screen. Never obtained on screen. Okay. Now, real images. For example, the images which we see from a projector, the images which we see on a wall, the reflections, the shadows, okay, all these are images are your real images. Okay, whatever images we see on a screen, on a surface in front of you, those type of images are called as real images. Real images are always and always obtained on screen. Virtual images, on the contrary, can never be obtained on screen. Okay. Third thing, real images are always inverted. Okay, they are always inverted. Virtual images are always erect. Okay, so if this is the object, this is the way your image will be formed. But for a real image, if this is the object, this is the real image. It's inverted. It's always and always inverted. Okay, so this was the differentiation between your real images and virtual images. I've just told you. See, real images which are obtained on screen, which is obtained on screen. It is obtained inside the mirror. Inside the mirror. So these are your virtual images. Real images always obtained on screen. Now you will if you are going through the lecture properly, you will just a thought will come in your mind. Like if ma'am is saying that, okay, real images are obtained on screen. We see projectors in school, we have gone through it. But real images are always inverted. So then why are we not seeing these real images? When we see images or movies on a projector, why can't we see inverted images? Yes, thought must have arisen in your mind. Because the what they do here, they keep the object itself as inverted. Okay, so if they keep the object inverted, they would get a image which is erect. Understood? So if it's inverted, they are going to get an erect image. If it is erect, they are going to get an inverted image. This is the way it works. So if you some of you might have gone to theaters, and basically not theaters only, basically from where the movie, like before 10 years, the movie used to be seen on the projector with the help of projector in movie theaters, small movie theaters. So when you go inside that theater room from where the movie is actually getting projected, you will see that movie is going upside down. So if the movie is going upside down on the screen, you are going to get a erect image. Understood? Yes. So that's your real image. Virtual images, whatever images you see inside a mirror, you may, even when you see yourself inside the mirror, you see yourself, right? So that's a virtual images. Virtual images basically means false images. Okay? Right. Okay. Now we will shift ourselves now from plane mirror to spherical mirrors. Okay? We studied the entire reflection phenomena on plane surfaces, how images are formed, what is the difference between real and virtual images, okay, and what are the different image characteristics of images formed by a plane mirror. Okay, but again, see, physics is all about curiosity. Unless and until you don't question the phenomena, what is happening, you won't be able to have interest in physics. Physics is everywhere. You just open your eyes, look left side, something is happening, that's physics. Look in front, just observe the people going from one end to another, observe animals, observe nature, that's physics. Everything is related to physics. If physics wouldn't have been there, our entire universe or the laws which are governing the universe wouldn't have been there. Okay? So make a habit to ask questions, create curiosity in your minds, right? So now we studied about plane mirrors. Okay, what would happen if these plane mirrors were made curved, either curved in this way or curved in this way? Again, have you ever imagined that? Can you imagine how would the images be formed if the mirrors would have been curved? You must have had a daily experience. Sometimes when you go to circus maybe or to a fun fair, there's a room wherein you see distorted images yourself. Okay, your head becomes big, your body becomes very small, your face becomes very distorted, your face is small, your body becomes big, and your legs are again small. Okay, so if you had ever observed the surfaces of these mirrors, those are called as funny mirrors. The surfaces of these mirrors are always curved. They are not plain. They are not like a plain mirror. Okay, they are always curved. Either they are curved inside or they are curved outside. Okay, even normally in our day-to-day life, we use these curved mirrors. Okay, now these curved mirrors are called as spherical mirrors. These are called as spherical mirrors, right? So now spherical mirrors, for example, when you go to a shopping mall, okay, you park your car, and sometimes, many times, even in shops, you must have seen this. The person who's sitting at the cashier's end has a big mirror above him. Okay, if you had keenly observed the surface of the mirror is a bulged out type. It's like this. It's like this. The mirror is like this. Okay, if you see over here. Again, have you ever seen your image inside a spoon? Okay, you know how the spoon is. Okay, the shape of the spoon. So this is the curved part inside and this is the curved part which is outside. This will give rise to two types of spherical mirrors. The inside curved part is called as a concave mirror. Okay, because it's a cave, it's going inside, it is called as a concave mirror. The mirror which is curved outside, for example, this part of the spoon, it is the convex part. Very important because the same terms are going to be there in your lenses part. Okay, see, I'll tell you, if you study spherical mirrors and if you study the phenomena of reflection thoroughly, refraction is not difficult at all. The laws governing would be on the same track. Images formed would be again on the same track. Okay, so it's very important for all of you to just have this basic knowledge thorough so that the upcoming topics would be easy to understand. Okay, so we'll be dealing with spherical mirrors. What are spherical mirrors? Spherical mirrors are basically curved surfaces, okay, which are used for reflection. Okay, now can you imagine, like, if the plane mirror is giving me an exact image of myself, how would images be formed in a spherical mirror, right? Would it be of the same size? Or would it be a smaller, or would it be a larger one? Would it be erect, or would it be inverted image? Just do an experiment. Take a spoon, take a nice shiny new spoon. See your image from the front side of the spoon. How do you observe yourself? See your image from the back side of the spoon. How do you observe yourself? Okay, try to do this. So now we come to our episode 2 of spherical mirrors. The entire information related to spherical mirrors, I will be dealing with episode 2. Okay, so go through this entire episode of plane mirror because the laws governing reflection are same, and we will study reflection in spherical mirrors. Two types of mirrors we are going to study, convex and concave. Okay, hope you enjoyed the video. Hope all the concepts which were taken up in the lower grades got revised. Go through it, prepare yourself, and soon I will be uploading a video for spherical mirrors. Stay tuned. Bye bye. Thank you.